Hey there, everybody, and welcome to the last big topic of the traditional Introduction to Computer Science part of the course. Recall that this course comes in two parts. There's an Introduction to Computer Science part that is very similar to any other material you might see at an Introduction to Computer Science course at KU or UMKC or any place like that. This is the last big topic of that part of the course, which we are wrapping up soon. The second part of the course is data analysis and data processing, an introduction to those things. This last topic serves as a segue between the two. So this video and the next one are sort of baby data analysis. We'll be crunching data from files where the files are not particularly sophisticated, but it serves as a nice segue, a nice bridge between the two parts of the course. So again, this sort of like crunching data from files in some sort of basic form you might see in like a UMKC course, but we'll move on to sort of data crunching in the next part of the course. That's pretty interesting and you won't see in a standard Introduction to Computer Science course. The goal of this video is to talk about how you read data in from a file. So you have a file out there and you want the program to know what's inside the file, and then you want to have the program do things like calculate an average of numbers in a file or find the maximum number in a file, things like that. That's what this video is about. So we're going to do two examples. One example shows how you read numbers in from a file. The next example shows how you read in string data from a file. So reading in numbers, reading in words or phrases, things like that. I'll show you two examples. Motivation. Why would you care about this? Well, we've written a program that does things like this. Lets the user enter by hand a list of numbers, and then we do things like calculate an average or like a median or whatever, some sort of computation. Now, of course, in general, people don't want to be handing you numbers one at a time like this. 10, enter, 20, enter, 100, enter. Who wants to do that, right? A lot of typing. So for most data sets out there, if you want to do things with the data set, like calculate an average, you're not going to write a program that forces people to type the numbers one by one. That would be terrible, right? Like, you need a really small data set to be willing to do that. So in practice, data sets are stored in files, and a program needs to be able to eat that file in, get the data from the file, and then do something with it. So that's why we're doing this, right? In practice, you're not going to have people give you information, or you yourself are not going to, within your program, hand type all the numbers. You're not going to do that. It'd be too time consuming if your data set is too big. So in this video, we cover how to get numeric or string information from a file. So first things first, if you want to access a file, you want your program to go find a file and then read in the information from it, you need two things to be true right now. So of course, for experienced programmers, these things don't have to be true, but for us right now, the things have to be true. First of all, the file that you want to process must be in the same place on your computer as your Python file. So what does that mean? So let me bring up my compiler. The file that I use to write code for you guys is called untitled10.py. That's my spider file. Untitled10.py on my computer is right here on my disgustingly messy desktop. Okay, I apologize. What a pain to look at this. But here's untitled10.py. In this video, I will be processing two separate files. One of them is called numbers.csv. That's right there. Also on the desktop. The other file is called texttwistwords.csv, which is right there. Also on the desktop. Now, I put things on the desktop because I'm lazy and because I don't mind looking at this disgusting mess. You might want to put things elsewhere. I don't care. The only thing that matters, though, is if you're going to put this untitled10.py, whatever that file is for you, if you're going to put that somewhere else beside your desktop, the files you want to process have to go with it. So you can't have these files on your desktop and then have your Python files somewhere else. So that's the first thing. So I guarantee you many of you will not do that, and you get an error message that's like, can't find this file, and that will be the reason why, because your file is some other place on your computer. Now, the next thing that needs to be true is your file needs to be either a text file, like .txt or .rtf, or a .csv, which is a spreadsheet. But it's a special kind of spreadsheet that's been kind of stripped down. But you can open .csvs in Excel or in Pages, and it'll look the same as a standard spreadsheet. But it's not a .excel file, .csv. Now, for all the examples I will do, I'm going to use a .csv because those have always worked for me. Every once in a while, I'll have students whose computers can't process a .txt, and I don't know why, or a .rtf, I don't know why. So I'm just sticking to .csv, but if you'd rather have a text file, that might work for you. Okay, so these two things need to happen before you do any coding. Your file you want to process is in the same folder, and it's probably going to be a .csv, maybe a .txt. Okay, now how do you teach the program what this file is? How do you eat this file into a program? You do it with a line of code like this. So see this command open? You're going to tell the program to open a file. Here you give it the file name. So you're saying, hey computer, program, right, Python, open the file called numbers.csv. Now the second parameter here, this R in quotes, that's just short for read. So you're telling the computer, I want you to open this file. What file? Numbers.csv. Why do you want that open? So I can read it. That's what's happening over here, right? Open this file so I can read in the information. And then that file has to be stored somewhere in your program inside of a variable. So the file is out there on your computer somewhere. It needs to be stored inside your program so your program can deal with it. So you give this thing a name. I call it my file. You can call it whatever. Okay. After you've opened the file, so the program knows what the file is, you can access the lines of the file with a command like this, .readlines. So my file .readlines reads in the lines of the file. So let me just show you what file we're going to process first. The first one we're going to process is called numbers.csv. It looks like this. It's a very small spreadsheet with just a single column. So all of the data files we're going to be processing for this unit of the course are like this. They are single column files. Now, once we move to the data processing portion of the course, we can process as many columns as we want. So of course in practice, right, most spreadsheets you want to crunch have lots and lots of columns. But for now, we're going to talk about how you eat in a file like this. Okay, so that .readlines command, what it does is it reads in the first line, reads in the second line, reads in the third line, and so on. It just reads in the lines, and it reads them in as a list. Okay, because if you think about what this column of data is, it is just a list of numbers. First number is 90, second number is 82, and so on. So you can just teach Python to read this column in as a list. And that's what's happened here with this .readlines. Now you have to store that list somewhere. So I've stored it in a variable called lines. You can call it whatever you want. Okay, so let me scurry up to my compiler now. So I'm going to do both those lines of code. I'm going to open numbers.csv. I'm going to read it. And then I'm going to tell Python to read the lines in as a list. So these two lines of code have done something pretty powerful. You've taught the program what file you want it to open, what file you want to look inside, and to read the data in. And then you've read the data in as a list. So I can just like print lines right here. I can look at what that list is. And look what it shows me. 90, 82, 55, 68, and so on. So let me show you the file again. Right? 90, 82, 55, 68, and so on. So this file is somewhere else. Like it's not part of your program initially, right? But you've taught the program what file you want, and you've taught the program what information to grab from it. And it did. You know, it created a list of these numbers. Now, you'll notice this list of lines here is not actually a list of numbers, actually. It's close. I mean, you can certainly see 90, 82, and so on, but there's some extra garbage here you don't want. So first of all, notice the quotes. Quotes means string information. So the program right now is not thinking of this 90 right here. It's not thinking of it as the number 90. It's thinking of it as the string, the English phrase 9 followed by a 0, which is not a number. It's English. So that's bad for us because presumably we're reading in numeric data so that we can treat it like numbers and do things like calculate averages. You can't calculate an average on strings, on English. You know, you can't take the average of the and high or something. It doesn't make any sense. So that's the first thing to note, is that the program read these things in as strings. So we're going to have to do something about that. Also notice this \n thing. That's like hitting a return key. It's the new line character. So notice in this file, right, 90, once 90 ends, you like hit enter and move on to the next line. There's a new line started here. The computer's reading that in. It's like, oh yeah, 90 is on the first line, I start a new line, 82 is on the next line, start a new line, 55, and so on. Okay, so again, if we want to read in this list and do arithmetic with it like averages and medians, we can't have these new line characters here. We can't have the quotes here. Think of it as strings. So what we have to do is we have to somehow sort of clean this up, right? We have to teach the computer, no, not symbol 9, symbol 0, \n, quotes, 90. Got to teach it that. So let me show you how to teach it that. I'm just going to create a copy of this list where that stuff has been stripped away. So here's how you do that. This always works, by the way. So for item in lines, the first thing I'm going to do is a command called .strip. What that does is it takes the new line character off. It's like, hey computer, I don't want that return key as part of my item anymore. And then you tell the computer, hey, that 90 string, no string place. Think of it as a number. So int of item turns the item into a number. So not 90 string, but 90 the number. So once you've done those two little bits of cleanup, you can then throw that item into list, sorry, not lines. Lines 1, I called it. Right, you can throw that into line 1s. And again, you can call this whatever you want. Doesn't matter. You control the names. So let me now show you what lines 1 looks like. So here's lines with a capital L. Here's lines 1. Notice lines 1 is what we want. It's like, oh yeah, number 90, number 82, no new line character, right? So if you read in the lines of a file, you always have to do this little bit of cleanup if they're numbers. So any program you write in the homework that involves reading in numbers from a file, you're going to have this sort of structure here. Strip away new line, turn it into an integer. So let me just show you what can go wrong if you forget things like this. Suppose I forget to make the strings into integers. If I run this, notice there's no new line anymore. It stripped that off because that line of code's still there. But it left the quotes on there. So it's not thinking of this as the number 90. It's thinking of it as the string 90, symbol 90. So you have to do both these things. Take the new line off and then think of it as a number. Okay, now with this in place, we're basically done with this topic because once you've read in this column from a file as a list, all of our previous material kicks in. So we did a bunch of stuff with lists, right? Like we calculated averages of lists. I mean, once you have a list inside your program, you can do anything that we did before. So in particular, my examples were, where's this? What did I want it to do as examples? I wanted to, where is it? Okay, calculate the average and maximum number in a file. That's one thing I wanted to do. Okay, so let's just do that. From previous videos, we have code that does that for a list. I'm going to grab both of them. Okay, so again, this is just previous material. This is not new here. Both these things appeared in previous videos or in previous homework numerous times. So here's a function where you can feed a list in and it'll return the average. Here's a function where you can feed a list in and it'll find the biggest number inside that list. So we've looked at both of these before. So now I can do things like this. I can say, hey, Python, what's the average of lines 1? Hey, Python, what's the maximum element of lines 1? And it'll just like do that. So the average is 76. The biggest number is 100. And we can see that, right? Biggest number is 100. Okay, so all that to say, and you don't need this anymore if you don't want it. These, 7 lines of code or something? This is how you process a column of numbers from an Excel spreadsheet. And once you have that list in your program, you can do whatever you want with it. Average, median, biggest number. You can count. You can count the number of A scores. These look like exam scores, right? Anything we've done before, you can do now because you've eaten the column of information from that file in as a list. So let me close this video by showing you a string example. Yes, that's what I just did, right? And let me just reemphasize this punchline. You read in the data in the file, clean it up a little bit, and then you have a list. We can do things with lists, right? We've done things with lists many, many times. Okay, so now let me show you a text example. So reading in strings. The process is basically the same, but let me show it to you anyway. So just to motivate, give a concrete example here. In the game Text Twist, which was big when I was in college, probably not so big anymore, the player is given 6 letters, and you got to find all words you can using those 6 letters, with the restriction that the word has to have at least 3 letters. So you're not going to do an, right? An only has 2 letters. So the game might start like this. It'll show you these 6 letters, and then you have to type things like hey, right? H-A-Y is in there, they is in there, right? T-H-E-Y is in there, hat, and so on, you know. So you just find as many words as you can from the 6 letters that they gave you. So, at this point in the course, we cannot write a text twist program. That's pretty complicated, but we can write part of a text twist program to answer this question. If you were to write a full text twist program, how could you verify that what the user typed was actually a word? You know, the user types in a string of characters. How do you know it's a word? Like if they type H-A-Y, you need to teach the computer that that's a word. The computer should be like, oh yes, legitimate English word. But if they type, you know, T-H-R, the computer should know that's not a word. How could you teach a computer that sort of thing? Words and not words. The answer is, well, among other things, but in this case, what if you had a file on hand that had all English words with 3, 4, 5, or 6 letters in it? Then the computer could just go to that file and check what the user typed against that file to see if they typed something legitimate. That's how you could teach a computer what a legitimate English word is. So let me just show you that. Okay, so again, this file is on my desktop, and it looks like this, text twist words. So it has all English words with 3, 4, 5, or 6 characters, or all such words that this game will accept. So, I mean, a lot of these don't look like real words to me. I mean, abac is a real word. Abaca with a K, I have no idea what that means, but I got this spreadsheet from like the Text Twist like official website a long time ago, so this is the real deal for that game. Abaca, like what's that? I don't know. Okay, so anyway, let me go here and let me get rid of the number stuff. And now I'm going to open up Text Twist Words. This file's on Moodle, so you can download this also and play with it. Okay, so same idea here. I'm going to read the lines. And once again, I want to make sure that I'm grabbing those lines as a list that's cleaned up. Now notice, let me take these out because it's mad. Let me comment this out for a second. Okay, so let me show you what happens now if you print lines. So this is not cleaned up. You just did the read lines. Let me show you what it does. Okay, it prints like the entire list. There's a lot of information, right? So notice now it knows everything's English. That's fine. I mean, the fact that zoomed, the fact that that's English, it's in quotes, that's fine. But it's got these new line characters on it. We don't want those, you know. You don't want to keep track of like whether of these enter keys. That's kind of obnoxious. So now when you clean up the file, you still want to strip that new line character off. You, however, most definitely do not want to turn these things into integers. This is not numeric data. So don't take the word zoomed and turn it into an integer. What does that even mean? So for string data, you take that out. Okay, so for string data, there's just one less line of code to like clean things up. So now if I do print lines 1, see, it's that same file information, but there's no new line character. So it's cleaned up. Okay, so now if you want to do things like, what do I want to do? I think I have a function here. Oh yeah, my goal was like the user gives me a word. I want to see if that word is in that dictionary or not. So here's a function that checks, given a list and given a word, it'll check if that word is inside that list. We've looked at things very similar to this before, so I won't belabor the point here, right? But you go item by item through the list. If you ever see that word you're looking for, throw a true back. If you never saw that word, throw a false back. So you let the for loop look for that word. If you ever see the word, the function terminates and tells you true. If you never see that word, the function tells you false. Okay, so down here, let's just finish the video by asking the user for a word. It's like user word, string input word. So they're playing text twist, right? And they're typing, you know, like zonked or something, whatever, right? They type something. The computer has to check if that's a legitimate word or not. So here's the check. If word in list, I feed the function the list of words, which right now is called lines1. You can call it something more useful if you want. So feed this function the list, feed the function the word. If that word, this word right here, if that word is indeed inside this list, if that's true, then print, you know, real word or something, whatever. Else, print not real word. So anyway, the game Text Twist, if you play this on a computer, it has some subroutine that does this. Check if what the user typed is actually in the dictionary or not. Okay, so I'm going to type a word, hat. It tells me that's a real word because it is. The word hat is inside this dictionary. You know, if I type, zounds is a real word apparently. Zounds. It's like, yeah, that's a real word. But if I type nonsense like this, thref, it says that's not a real word because it never found that word inside this dictionary. So this is pretty neat, you know, if you think about it, that you just had the computer crunch, not this file. Where's the file? This file is huge. Okay, so scroll. I mean, there's a lot of words, right? A lot of English words of length 6 or smaller. I mean, I probably can't make, I'm on line 8,000, I'm only in the F's, right? I'm pretty sure this file has like 28,000 lines in it. I don't know, it goes for a while. 27,000 lines in it. The computer can process that information instantaneously, right? See how fast that is? So when I type zounds, boom, it's like, that's a real word. It knows that immediately. Like it can just process those 27,000 lines from our perspective instantaneously. That's pretty neat. Okay, so anyway, so at the end of this video, I've shown you how to eat in numeric data or English data, assuming it's one column of a file. So your file has to look like this, file has to look like this. Once you've read that data in, you can do whatever you want with it based on the previous material we've already covered. So again, this function was perfectly legitimate before. We've looked at things like this similarly before, and it's perfectly fine now. You just have to read in the file so that it's a list. And then once you have a list, you can do whatever you want with it. Okay, so in the next video, we'll talk about how you take information and write it to a file. This line of code here, right, reads a file, but we're not changing the file itself, or we're not creating a new file, things like that. The next video will do that.